the last one. This is it. So it's just, yeah, I guess maybe just, well done, right? I reckon we need it. Let's go make it, maths. Come on. So, the letters from the word statistics are randomly arranged. So, what is the probability? So we're going to have to look at the total number of ways of doing this. So to start with, what we did before is we said, well, the total number of letters we've got in the word statistics is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 letters altogether. Now let's go and see what we've got in terms of repeated letters, because our formula is going to require us to use those repeated letters. So we've got, I was going to go in alphabetical order, but you could go in any order you like. So the way I'd figure it is, we've got number of A's, well, there's one A. Then the number of C's we've got, I'm going to run out of letters, I'm sure, colors. C's, there was just one C, but we're really interested in the ones that are doubling up. So it looks like there are a few I's here. In fact, there are a couple of I's. Two. So I'm going to write my I like an I like that, so it looks different to a 1. So there are 2 I's. And then we can go, I think S is going to come next. So S gives us 2 or 3 at least different S's. And then our T's, well, let's see. T's, look, do teals, that would be teal, that would be good. But let's go orange. So 1, 2, 3 different T's, and let's just check. So 3, 3, 2, 1, 3, 1 gives us 10 letters altogether. Okay, so let's just see the total number of words that we could form with this. So forget even what the question says about, the word starting and ending with the same letter. We first need to see the total number. So your formula. I'm not going to ask you to write down your formula. It's a pity, it's just going to be too difficult for you to write down. But confidence level, look back at the previous examples. What's our formula going to look like? But you don't ever say what it's going to look like. Like, how are you feeling writing it down? And perhaps, what's your final answer? Okay, well, let's work our way through it. There are 10 letters altogether. So there are 10 different kind of ways that we're placing, 10 different positions here. Then we're going to look at the repeated things. I'm going to ignore these ones here that don't repeat. But we're going to say that there are 2 different ways of doing I. So they're 2 factorial. We need to multiply. Then we've got 3 S's. So we need to multiply that by 3 factorial. And finally, we need to multiply it by 3 factorial for the T's. And we're dividing by those. Okay, and into the calculator it goes. And I don't know. Perhaps or perhaps not, you wrote 50,400 earlier. I don't know. Well, more importantly, hopefully understand this a little bit better. Okay, so now we need to look at the probability. So we're going to see how many different ways we can write a word that starts and ends with the same letter. So for this, we need to kind of think through a few different options. So I'm going to draw my beloved boxes. 1, 2, 3. I think I'm going to try and learn to count today, though. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got there, right? So we got 10 different. Yeah. Now we need to consider 3 different options, because the first option is that we've got an I to start and end. So we've got an I and an I. Why can't we start and end with an A? There's an A over here. There's only one A, so we can't have A and A. So that's our one option, and then we can fill in the rest of the letters. Now, similarly, we could also do it with our S's. So I'm not going to draw my blocks now, but we're going to could start and end. So the blocks help line things up. We've got an S and an S, or we could have finished with a T and a T. So we're going to be looking at these different options. So we're going to say it could start and end with I, or it could start and end with S, or it could start and end with T. So already know we're going to get these 3 things and we're going to add them together to see the total number of ways. So if we've started and ended with I, let's have a look what's happening in the middle. So now we've got, how many blocks do we have to fill in the middle here? Well, they're 8, right? So for those 8, let's just look at this first option here. So for our first option that has I, something other than I, for those 8 in the middle, we're going to say they're 8 to fill in, and now we need to factor in how many repeated options are there. Well, we've used up our I's, so we can kind of cross that out in terms of our repeated options, and we've got 3 S's and 3 T's. So we've got 3 S's and 3 T's. So that's our option over here. So this is 8 factorial, 3 factorial. Okay, then if we do the same with our S's, now for our S's, we've got also 8 blocks to fill in the middle over here. And for our 8 blocks, we've used up 2 of our S's. So I kind of cross out because we've only got 1 S, so we don't have to worry about that being repeated. So we've got the 2 repeated I's and the 2 repeated T's. So in our formula, let's just show that separately. For our option that goes S, something or other S, there's still 8 different blocks to fill in. But this time, we don't have to worry about the repeated S's. It's just the 2 repeated I's and the 3 repeated T's. So that's what this is going to be. Still 8 blocks to fill in, and we've got the 2 repeated I's and the 3 repeated T's. And finally, for our T, and then 8 blocks, 6, 7, 8, then our T's again, if we look at that, we're going to go, well, we've only got 1 T left, so we don't have to worry about it repeating. So our repeated options are the I's and the S's. So kind of with a bit of luck, we're getting the hang of this to go, well, for our T, something or the T, there are 8 blocks to fill in. What we need to kind of factor in are our I's and S's, and we've got 2 repeated I's, and I think there were 3 repeated S's. So for this one, we've got 8 factorial, and shouldn't have written it down there, 2, 3. 2, 3. So if we add up all of these options here, that's the total number of ways we could have the first and last letter repeating. So if we add all those up together, I don't know if I wrote down what I got. I think I got 7,840. So that's how many different combinations could start and end with the same letter. Okay, so our probability, I'm just going to move over here so we can do it together. So our probability of starting and ending with the same letter is the number of ways that could happen divided by the total number of options that there were. Earlier we said there were 50,400. So if we punch that into the calculator, we get 0,155555555. So you could round off or use this little dot above. Okay. Last example. Let's hit it. Okay, so for the last one, statistics are randomly arranged. Cool. So we still have the same scenario that we know of before. But this time, we asked, what's the probability that all 3 T's will be together? So we still know that the total number of ways of arranging this is 50,400. Now let's think about these blocks. And for the last time, these dreaded blocks that should become lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10 letters for statistics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to see how we can have the 3 T's together. So there definitely were only 3 T's. So let's have a look. We could have the 3 T's together over there, right? We could have the 3 T's together there, and so it would go. So if we counted all of those options up, we should hopefully get that there are how many different options? Well, I counted up 8 different options. So there are 8 different ways we could kind of group the T's. Now within the group of 3 t's, so if we're just looking at t's and we're arranging 3 t's, how many different ways could we arrange the 3 t's? Well, there's only one, because it would have to be t, t, t. And remember, we considered that the same as t, t, t. So it's not like there was t1 and t2 and t3 and they could change around. T, t, t is t, t, t. So there's only one way to arrange that within it. Now we need to look at arranging the others. So we've got 7 blocks left. So if we've arranged our 3 t's, t, 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 doesn't matter where they are, we've definitely got 7 other blocks to fill in. So we've got 7 other blocks, and now we need to look at how many other things are repeated. Well, if we look back up here, our repeated letters, let's just actually copy it down so we don't have to look at all of that other stuff and get confused by it. We've got the 3 t's, those were repeated, but we've already accounted for them. So we've got the 3 s's and the 2 i's. So therefore we need to divide this by the 2 i's and the 3 s's. So let's just move that so that was out of the way. And in fact, that's fine. I was going to move these 3 t's. Let's get them out the way. So therefore, straight into the calculator goes, and we can see that if we multiply that, we get 8 times 1 times, this becomes 420, and we get 3360. So there are 3,360 different ways that can happen. And so our probability of the 3 t's being together, so sweet, is that we've got 3,360 ways of that happening out of the 50,400. Is that right? No, 50, I don't know. Lots, big numbers, right? Not 54,000, 50,400. So into the calculator it goes, and we get 0,0 what recurring. Oh, I know. But for that last bit, you're like, finally, it's just going to talk through. But that wouldn't happen, would it? So I think we need to just end on this. Yes, we're done. Oh wait, the video isn't finished. I need to, where's the pause button? Okay, goodbye.